Now we're going to look at using the side-side similarity theorem, side-side-side similarity theorem. So what does that mean? When we say side-side-side, we are saying that all three sides are proportional. So how did I do that? I created a random triangle here, and you can actually move all 3 points. And I created the second triangle by just applying a scale factor to the first triangle. So the only rule is that, in this case, if the scale factor is 1.8, if I go 1.8 times 32.9, I better get about 59.3. These are rounded, so you might get a slightly different value on your calculator. And if I go to a scale factor of 2, you should see that it is doubling. And again, they're rounded, so sometimes they don't quite match. So here you have 33.2 and 66.4. Now the question is, if I make this triangle, right, is it going to be similar by applying the scale factors? Are the sides going to have a constant ratio? So what I did is I made these ratios of the corresponding sides. Here, the red to the red, blue to blue, and green to green. And you can see that the ratios are actually matching the scale factors that I created. Well, that's good. All sides should be proportional. But are all the angles congruent? So let's take a look. Here are the angles I'm getting on the first triangle, and here are the angles I'm getting on the second. So the red angles match, the green angles match, and the blue angles match. So it looks like all three sets of corresponding angles are congruent if all the sides are proportional. And you can see I can change the scale factor and the angles are still congruent. I can even change the angles and they still match. So we can conclude that all of the angles are congruent if all the sides are proportional. Okay, so this leads to the side-side-side similarity theorem, which says if three sets of corresponding sides of a triangle are proportional, then the triangles are similar. Now we're going to do an example. And there are a couple different ways to do this problem. I'm trying to find out which set of sides are proportional. And while I was debating how to show you how to do this problem, I thought, you know, the simplest thing to do, if they're all proportional, that means they're equivalent ratios. When you were in 6th grade, if I gave you the fraction 8 over 10, you would simplify that to 4 over 5. Or say I gave you the fraction 6 over 8, you would simplify that to 3 over 4. So let's say I have 6 over 8 is the same as 3 over 4. And including 12 over 16 is the same as 3 over 4. The easiest way to compare fractions when you were in 6th grade was to simplify. So what I'm going to do is try and go back to the original smallest triangle, the simplified one, that is similar to all three of these. So I'm going to simplify all these sides by their common factors. Additionally, I'm going to identify which sides are the smallest, the medium size, and the longest. And I did that here. So I went ahead and labeled them all. On this first triangle, you can see all three of these numbers are divisible by 4. So I divide by 4 there. That's 2, 3, and 4. On the second triangle, I'm trying to get the biggest number in, which would be the greatest common factor if you remember 6th grade. And that would actually be 8. So I get 2 for the smallest side, 3, and then 6. For the last triangle, the number that goes into all three of those are 6. So I get 2, 3, and 4. There are 2 triangles that match here, the first and the second. And then finally, I need to write a similarity statement. So I need to match vertex to vertex. So, for example, angle B, which is between the small and medium leg, has to go with angle E, which is also between small and medium. C has to go with D, and A goes with F. So now I get my similarity statement. ABC goes with, oops, I need to fix that. Here, let's fix that right now. ABC is going to go with FED. So not EDF. I think I just typed that in, and I'm using my mouse. My handwriting's terrible. There you go, FED. So for further reflection, Why do triangles have to be similar if all three sets of sides are proportional? We used inductive reasoning to show that by looking at two triangles and making them similar, making the sides proportional, and we saw they were always similar. We were not able to find a counterexample. What strategy is useful when you don't know the similarity statement, but you do know all of the sides? Well, honestly, simplifying to the simplest ratios to go to that first polygon or triangle is easiest. And then also for your individual practice problem, how can you find missing sides if you know the scale factor and the pre-image sides? So here's a hint. Take your pre-image sides, multiply them by the scale factor, and they should match with the image sides. Remember, image is equal to scale factor times pre-image. Remember to match up the longest with the longest, the medium with the medium, and the small with the small.